The steel arriving at Bath Iron Works today will become the hull of an Arleigh Burke-Class destroyer.
The Aegis Combat System components arriving at Bath today represent the most capable naval air defense electronics in the world. The Mk-41 vertical launch system components stored here will give the Arleigh Burke destroyer the ability to carry and...
DH-36 naval steel has a yield strength that allows the Arleigh Burke hull to be built a little lighter than older destroyer designs.
The material certification review at Bath Iron Works is conducted under Navy program oversight. Every material specification.
A single DH-36 naval steel plate for the Arleigh Burke hull weighs several tons and requires industrial...
Every hull plate is ultrasonically inspected for internal laminations, voids, and inclusions before it enters hull assembly.
When the Bath Iron Works shift ends, the steel rests in the Maine cold. Tomorrow, the cutting begins.
The Arleigh Burke destroyer is built in modules, large pre-outfitted structural units assembled on land, then lifted and...
The Arleigh Burke rudder stock must transmit the full steering moment of the hydraulic steering gear to the rudder blade at speeds exceeding 30 knots in heavy weather.
The General Electric LM2500 gas turbines arriving at Bath today each produce over 25,000 shaft horsepower.
Cut, formed, inspected, and ready. The DH-36 steel components staged here in Bath will be welded into the first module of the Arleigh Burke destroyer.
Stress relief treatment of formed Arleigh Burke hull steel removes the residual stress.
Rolling DH-36 naval steel into hull shell plate curves requires a machine exerting.
The Bath Iron Works CNC floor machines components for the most capable surface combatant in the United States Navy.
Bath Iron Works warehouse holds the materials that will become a United States Navy destroyer. The Kennebec River flows a few hundred yards from where this steel sits.
The plasma cutters at Bath Iron Works follow programs generated from the Arleigh Burke digital ship design. Every cut produces a plate blank.
The transverse hull frames cut from DH-36 steel here are the ribs of the Arleigh Burke destroyer.
The Arleigh Burke propeller shafts transmit over 25,000 shaft horsepower from the LM2500 gas turbines to
The Arleigh Burke stern section carries the propulsion system shafts, the rudders, the sonar transducers, and the gas turbine exhaust uptakes. Naval bronze castings for the Arleigh Burke seawater systems must resist corrosion in the marine environment for the full 30-year service life of the destroyer.
The CMM inspection of Arleigh Burke propulsion shaft couplings verifies that the mating faces are flat and parallel.
The SPY-1D phased array radar faces on the Arleigh Burke superstructure must be aligned to provide sync to ship's angular.
The Arleigh Burke superstructure uses aluminum alloy for topside structures to reduce the weight high in the ship that would otherwise degrade stability.
The Mk-41 VLS cells machined here will carry and launch the full spectrum of American naval weapons.
Naval steel chips are heavier and tougher than ordinary structural steel chips. The cutting tools that machine them are rated for marine-grade steel and changed at intervals.
The machining program executing on this screen was validated through Bath Iron Works engineering review before production began.
Every primary hull weld on the Arleigh Burke is ultrasonically inspected through its full cross-section. The scan data is reviewed against naval vessel weld acceptance criteria.
The AN/SQS-53 bow sonar dome houses the most capable hull-mounted sonar system in the American.
The Arleigh Burke hull structural inspection is conducted jointly by Bath Iron Works quality engineers and Navy shipbuilding program representatives. Before installation, each LM2500 is inspected for transit damage and all classified systems verified.
The LM2500 vibration isolation mount system prevents gas turbine vibration from propagating into the Arleigh Burke hull structure.
The seawater cooling system carries ocean water through the destroyer's cooling circuits, keeping the LM2500 turbines.
Welding the Arleigh Burke aluminum superstructure requires different techniques, different consumables, and different quality standards than the DH-36 hull steel.
The Arleigh Burke destroyer hull is complete. DH-36 naval steel cut, formed, and welded by the skilled workers of Bath Iron Works, Maine.
The Arleigh Burke destroyer takes its final form on the Bath Iron Works building way. Modules fabricated in the
The Arleigh Burke controllable pitch propeller allows the ship to change propeller blade pitch without changing shaft speed. The propeller shaft alignment is one of the most critical measurements in Arleigh Burke construction.
The Aegis Combat System computers process SPY-1D radar data, correlate it with identification friend or foe returns.
Every weld pass on the Arleigh Burke hull must achieve full fusion with the DH-36 parent plate and maintain the mechanical
areas. The Arleigh Burke main reduction gear reduces the 3600 RPM output of the LM2500 turbines to the 100.
The module lift is the moment when months of fabrication and pre-outfitting become a ship. The gantry crane that lifts this module.
The Arleigh Burke carries enough diesel fuel oil for over 4,400 miles at 20 knots.
Pre-outfitting the module before assembly is the core innovation of Bath Iron Works modular construction. Every wire,
The AN/SLQ-32 electronic warfare system detects incoming anti-ship missile radar seekers.
the Arleigh Burke destroyer communications suite connects the ship to every element of the joint force. Aircraft overhead, submarine.
4 GE LM2500 gas turbines, 2 reduction gearboxes, 2 controllable pitch propellers, 3
of engines. The Aegis Combat System is what makes the Arleigh Burke destroyer the most capable surface warship in the world. The
SPY-1D phased array radar has no moving parts. It steers its radar beam electronically. The Arleigh Burke Combat Information Center is where the commanding officer fights the ship. The consoles installed here display the Aegis.
The AN/SQS-5D3C is the most capable hull-mounted sonar in the surface fleet.
In full Aegis system integration test, the SPY-1D radar feeds track data to the Aegis weapons control system.
The military specification anti-corrosion coating applied to the Arleigh Burke hull exterior will protect the naval steel through 30 years of operation.
The Arleigh Burke contains hundreds of miles of electrical cabling that must be routed to specifications designed around survival.
The anti-fouling coating on Arleigh Burke hull bottom prevents and other organisms from attaching to the hull.
The Arleigh Burke has its eyes and its brain. The SPY-1D radar that sees.
The Arleigh Burke damage control system is designed to keep the ship fighting through battle damage that would sink any previous destroyer class.
Haze gray, the color of the United States Navy surface fleet for over a century. Applied over the anti-corrosion primer, it gives the Arleigh Burke its operational identity.
Ponzi Burke's leveling. The Arleigh Burke hull surface is blasted to near white metal before any coating is applied.
The Mk-45 5-inch naval gun can fire a 70-pound projectile to a range of 13 nautical miles.
The Arleigh Burke carries a crew of over 280 officers and enlisted sailors who will live and work aboard.
The Arleigh Burke weapons safety system has multiple independent layers of interlock between the commanding officer's weapons-free authorization and the weapon leaving the ship.
The Phalanx CIWS is the Arleigh Burke's last line of active defense against anti-ship missiles that have penetrated the Aegis system's engagement envelope.
The VLS system functional test verifies every element of the weapon launch sequence, from the Aegis Fire Control System command through the VLS weapons control system.
The Mk-32 torpedo tubes fire Mk-46 and Mk-54 lightweight torpedoes for anti-submarine warfare at close to medium range.
The Arleigh Burke surface inspection is joint between Bath Iron Works and the Navy because both carry responsibility for the ship that will go to.
The VLS deck structure and gun mount foundation must withstand the dynamic loads of weapons firing repeated thousands of times over the destroyer's service life.
The final Arleigh Burke dimensional survey confirms that the ship as built matches the naval design at every critical measurement location. The Bath Iron Works chief shipbuilder's final inspection is performed by someone who has built these ships for decades. The Aegis Combat System acceptance test is the most demanding electronics verification in American shipbuilding. The Bath Iron Works chief shipbuilder's final inspection is performed by someone who has built these ships for decades. Full integrated systems test, every system on the Arleigh Burke operating simultaneously. The Aegis Combat System must talk to the crew that will take this destroyer to sea is assembling on its deck for the first time. They have not yet met the ship they will call home.
Built in Bath, Maine by American hands that have built warships for 2 centuries. armed with the most capable naval combat system in the world.
Sea trial preparation begins with every system check that was performed in the shipyard repeated at sea. The ocean and
Gun, missiles, torpedoes, electronic warfare, and the most capable naval radar system in the world.
The Arleigh Burke destroyer sits at the Bath Iron Works fitting out pier in the final stage of its construction. The Kennebec
The Navy acceptance inspection of an Arleigh Burke destroyer is performed by officers who will be responsible for the surface warfare squad. Complete. Every system installed, every weld inspected, every test passed, every Navy requirement met. This Arleigh Burke destroyer is ready for the United States Navy.
The Arleigh Burke destroyer leaves Bath Iron Works for the first time. The Kennebec River carries it toward the Atlantic.
The Navy acceptance inspection of an Arleigh Burke destroyer is performed by officers who will be responsible for the surface warfare squad.
the crew that will take this destroyer to sea is assembling on its deck for the first time. They have not yet met the ship they will call home. The Aegis System sea trial tests the SPY-1D radar and the complete Aegis weapons control system in the actual...
The helicopter deck landing qualification confirms that the Arleigh Burke flight deck systems, RAST, fueling, and lighting, operate correctly at sea.
Complete. Every system installed, every weld inspected, every test passed, every Navy requirement met. This Arleigh Burke destroyer is ready for the United States Navy.
The Arleigh Burke destroyer leaves Bath Iron Works for the first time. The Kennebec River carries it toward the Atlantic.
Built in Bath, Maine by American hands that have built warships for 2 centuries, armed with the most capable naval combat system in the world.
Sea trial preparation begins with every system check that was performed in the shipyard repeated at sea. The ocean and... The Aegis System sea trial tests the SPY-1D radar and the complete Aegis weapons control system in the actual...
The helicopter deck landing qualification confirms that the Arleigh Burke flight deck systems, RAST, fueling, and lighting, operate correctly at sea.